We work so closely with Dozer and have known Jennifer for 10 years. She is one of the best communicators, thinkers, and talkers about the interplay of religion and science. The whole Dozer team does wonderful work on this. And I encourage you to be able to learn about the work that we're doing and the work that Dozer is doing about how can we better integrate this work of Judaism and science. And so I'm actually going to stop talking because I want to be able to hear from Dr. Wiseman and from Rabbi Yanklowitz here on these presentations.
Amazing. Thank you so much, Rabbi Middleman. And Dr. Wiseman, by way of introduction to our community, usually when people say Jewish adult learning program, they mean Judaism 101, kind of, what is this? How do you do that? Or the like. And Valley Beit Midrash is a little bit of a different model where we kind of shoot for the stars, if you will. And so we are shooting for a sophisticated audience seeking to challenge people on a high level. And so that is part of our goal today as well. And we are honored to have you with us. We're also honored to partner today with Temple Solel, who is a co-sponsor of today's program. Temple Solel, one of the synagogues here in our community. So just a brief introduction, which doesn't in any way do justice to the work you've done, but we'll give folks an introduction of where you're coming from. Dr. Jennifer Wiseman is an astrophysicist and the director of the Dialogue on Science, Ethics, and Religion program of the American Association for the Advancement of Science. She studies the process of star and planet formation in our galaxy using radio, optical, and infrared telescopes. She is also interested in national science policy and public science engagement and served as a Congressional Science Fellow of the American Physical Society. Dr. Wiseman studied physics at MIT, co-discovering comet Wiseman-Skiff in 1987, and continued in astronomy with her doctoral research at Harvard. She has worked with several international observatories and is currently a senior astrophysicist at the Goddard Space Flight Center. Dr. Wiseman is a fellow of the American Scientific Affiliation and frequently gives public talks to schools, congregations, and civic groups on the excitement of scientific discovery. She grew up on an Arkansas farm, enjoying late night stargazing walks with her parents and pets. I love that. I love that. That's really wonderful. So friends, if you're just joining us, and yeah, please do check out that link that Rabbi Middleman posted over there. If you're just joining us, the plan is to have about 30 minutes, give or take, of a presentation, and then a chance for some back and forth dialogue. And to end.
You said 45. Now you've dropped it to 30. So.
Oh, did I drop it again? Okay, 45. I mean. Yeah.
Okay.
I mean, yeah. Sometimes random words slip out of my mouth. 45 minutes, give or take, and then we'll have the chance for some back and forth here. So, so thank you all so much for joining us, Dr. Wiseman. The floor is yours.
Thank you so much. It's really fun and an honor for me to join you today. We're going to just allow our minds to kind of think big for the next hour. Can you hear me okay?
Oh, yes. And Dr. Wiseman, but yes, we can hear you. And before I also want to share that while you can see a certain number of people in the room, this is recorded and we share it in a dozen social media channels where thousands of people will access this content around the world. And so that's not meant as a form of pressure, as much as to say you're speaking to those in the room, but also beyond the room as well.
Certainly. Well, welcome to everyone. And in honor of the fact that this program, I guess, from your perspective, is originating in Phoenix, I'm wearing the most Southwestern oriented top I could find. So trying to imagine being in a nice sunny clime. Anyway, let's go together for a little jaunt through space and also in our minds, thinking about what we're learning about the universe, using the fantastic technology we now have in this day and age, and then how that fertilizes deeper thought about where we fit in to this vast universe. And it feeds bigger questions of significance and purpose for life in the universe. And that's going to be hard to kind of completely cover in a short hour, but I think we will enjoy, and I'll enjoy hearing also back from you, your thoughts. Now I'm trying to share my screen and it says that the screen sharing has been disabled. So can you?
Oh, sorry about that. Okay, Eddie, if you're able to make her a co-host there.
Yeah.
Okay,
So while they're
there you go.
fixing that, I would like
No,
to
you
just
should be good now.
hope that everybody here has been able at some point in your life to go out to a dark place and just look up with your own eyes. That's my favorite kind of astronomy. Okay, can you see this all right? Okay.
Good.
I
Yes.
didn't hear anything but okay, so let's talk about life and significance of life in a vast, awesome, I would say, universe today. Um, I want to first spend the first part of this talk just showing you some of the images, some of the ways we're learning about the universe in astronomy and other types of space exploration. This, for example, is a beautiful image of stars, a globular cluster of stars. So stars can sometimes be solitary, but sometimes they're in binaries or triples, and sometimes they're in very congested groups, big cities. And this is an example of a city of stars called a globular cluster toward the center of our own Milky Way galaxy. And I always show this image because I just think it's absolutely beautiful. You can see that stars are like gemstones. They come in different colors based on the different temperatures of their outer atmospheres. If our own sun were in a crowded city like this and we could get far away to look back, it would look like one of the smaller stars, the smaller whitish dots here. And astronomers will go further and look in each individual star and see what its spectrum of light is like, and tells us something about the composition, even the age and history of each star. We're able to see these stars and to differentiate them from each other. The light's not all blurring together with this precision resolution based on using a telescope in space. And this was just a calibration image of the newest camera on, in this case, the Hubble Space Telescope. And it's so beautiful that we show it in many ways and places to give us a sense. And this is the kind of thing that we don't often get to see with our own eyes. It's too bad in today's world that light pollution has basically made it nearly impossible for most people to see the night sky in all its majesty, to just walk out and be blown away by what we see. And yet that's been such an important part of human life and human contemplation for all time. The irony is that even though our night sky is often light polluted, the telescopes that are seeing such precision detail like never before are making those images available through the internet. So now people who have good internet connections can see things from the heavens easily and for free that we would not otherwise know about or be able to see. Things like this, beautiful nurseries where stars are still forming. Stars, in fact, are still coalescing out of interstellar gas. The turbulence in these interstellar clouds creates pockets of gas that can sometimes be dense enough to collapse under their own gravitational pull. And if there's enough mass collapsing in, it will create enough pressure to ignite fusion in the core of this little ball of gas. And fusion is a process that turns hydrogen into helium and eventually heavier elements. And that process also creates an outflow of light, of photons. And so that's what a star is doing. It's a little fusion factory. And the bigger stars form faster in these regions, and they spew out winds and also energetic radiation that goes back into the surrounding gas out of which the stars are forming, and can light it up through ionization. So we see these beautiful colors, and also can kind of blow it away by carving out structures and pushing away the less dense material. And so we see these marvelous regions where stars have recently formed. Lower mass stars are still in the process of forming in the leftover gas, which is being lit up by the bright massive stars. We use different kinds of tools right now in astronomy to study the universe. We use telescopes on the ground and in space. So here's just some examples. The one on top is a telescope in space. It's orbiting the Earth. This is the most famous one. It's the Hubble Space Telescope. It's about the size of a school bus. and it's operating right now, and it's in orbit around the planet, low Earth orbit. So it does the entire orbit in every about 97 minutes. So about every hour and a half, the telescope goes all the way around the Earth, and yet it's very stable. It can fix its point on a distant star or galaxy and provide high precision images, transmitting them back to the ground. The reason this, and there are quite a few other space telescopes as well that have different skills, if you will. The reason they're up there is to get them above Earth's atmosphere, because Earth's atmosphere can blur the light, the images. It can also filter out some types of light that we want to see, like ultraviolet light. But there's still some excellent astronomy that we can do from the ground. And so there are telescopes on tops of mountains, like the Kitt Peak telescopes in the lower left, or radio telescopes that see longer, lower wavelengths of light and radiation, such as the ALMA Observatory array of telescopes you see in the lower right. They're in South America. And so astronomers take data from many different types of telescopes and then correlate it to get a better understanding, a bigger picture of what it is that we're trying to learn, whether it's something about planets or something about stars or galaxies, or even the universe as a whole, or that wispy interstellar gas and dust between stars or between galaxies. And in fact, there's much beauty and much activity. One of the things we're learning is that the universe is not stagnant, it's active. Here's an image from the Hubble Space Telescope celebrating its 30th anniversary of operation last year. And this is an image from a region in the little sister galaxy next to the Milky Way called the Large Magellanic Cloud, where stars are still forming, and those massive stars are lighting up and carving out structure in that upper reddened nebula. The colors represent the different kinds of elements in the gas, mainly nitrogen and hydrogen. The lower left is one star that's a big, massive Wolf-Rayet star that has periodic or episodic expulsions of its outer atmosphere. And so it looks to us like a big donut. That's basically a big burp of this one very bright, very massive star. So the universe is beautiful and it's active, and it's our tools that are letting us see these kinds of details that we would not otherwise have ever seen or known about. And in fact, the tools have changed and advanced rapidly. So here is a view from the cockpit of the space shuttle when the astronauts last went up into orbit around the Earth to visit the Hubble Space Telescope and to do a servicing mission where they would upgrade some of the instruments and repair some things. They did this last in 2009, and you can see out the window of the cockpit there, the Hubble telescope, which temporarily was docked in the cargo bay of the shuttle for these kinds of repairs and upgrades. And one of the astronauts, John Grunfeld, brought with him what you see in the foreground there, which is a model of Galileo's telescope. This is the telescope that Galileo used 400 years ago to record observations of the heavens. And he recorded motions of the bright lights next to Jupiter, which turned out to be moons orbiting Jupiter, and other things that gave evidence of how our solar system worked. And it corroborated the idea, the Copernican idea, that the sun was in the center of our solar system. And so technology from this telescope Galileo used to Hubble has advanced rapidly in terms of human history, to the point where we're now using much more sophisticated telescopes to see much more detail than Galileo could see. But the kickoff was the idea of using this kind of telescope or this kind of optics and technology to study things about the universe in a scientific way. And we're exploring the universe in many different ways. We use telescopes for our solar system. We can also use probes. And so I hope you're all cheering on the Mars Perseverance rover, which recently landed successfully on the surface of Mars. It has dozens of cameras on board, and it can even scoop up samples. And hopefully a follow-on mission will bring those samples back to Earth so we can study what's in the Martian soil and whether there has in fact been life on Mars in the past. We know there was liquid water on Mars in the past, and we wonder what kind of environment that may or have produced that might be similar to what Earth's environment was when life began here. And here's a view from Perseverance looking out over that, what is now a very cold and barren landscape of Mars, but it wasn't always this way, apparently. We've learned that our universe is beautiful, it's active, it's enormous, and it's progressive. And I don't necessarily mean that in a political sense, but it's changing and becoming more hospitable for life over cosmic time. So let's look at some examples of that. Here's another gorgeous region of star formation in our galaxy, where you can see a massive cluster of stars and the leftover gas being lit up by those stars, even as lower mass stars may still be forming there. We use different kinds of telescopes also to get different perspectives. So here we are back to the core of that globular cluster that I told you about, but it's really hard to get a perspective of this. So if we look with a different telescope that has a much wider field of view than the Hubble Space Telescope can achieve, we can get a sense of the context of this thing. So this is an image from a telescope on the ground looking toward the center of our galaxy. And you can see lots of stars along the plane of our galaxy in this direction, and lots of dust along the plane. That's what that stuff is in the lower left there. Lots of bright stars, although it turns out that some of those stars, or what look like stars, are actually entire clusters. And we're going to zoom in now on, this is the Centaurus constellation. We're going to zoom in on one of those objects and then transition over to the Hubble Space Telescope image. So if your internet connection here is good, you can see that as we transition to the Hubble image, we're seeing that that one object is actually this entire cluster of stars. That's the Omega Centauri globular cluster I told you about. So we learn better when we have different kinds of eyes, different kinds of telescopes that can give us a different sense of context and of how things fit together. Some people like to see that twice, so we'll see if this works well. Okay, so there's that, what looked like one big star, but when we transition over to a telescope that doesn't have the big field of view, but sees more detail, we can actually see the individual stars in that dense globular cluster. Old stars are also important. This is an aging star that's beginning to become unstable. It's running out of a constant supply of hydrogen in its core to stably support that fusion process, and it's releasing its outer atmosphere. So here you see this star really going through its death throes, but it's beautiful. We call it, this one, the butterfly nebula, because the old star you can't see is buried down in the center here, but its outer atmosphere is being expelled at a very high rate of speed, and the heavier elements forged in that star are being expelled and mixed in with the interstellar medium, and they're available for subsequent generations of stars. Here's another ground-based image of a region of the sky you're probably familiar with. This is the Orion constellation, big field of view. You can see the bright star Betelgeuse in the upper left and the bright blue star Rigel in the lower right. In the middle is a group of stars that always looked like a kite to me when I was growing up. But if you look carefully at those individual stars, you'll see fuzziness. We call it nebulosity around each one. Now, if you do the same thing and look in more detail with the Hubble Space Telescope at one of those stars, it turns out that's not just one star, that's a group of stars. And I'm going to now show you the Hubble image, which doesn't see this big field of view. It's honed in on that one little spot where that arrow is pointing. And that's what you get, the Orion Nebula. And again, it's a cluster of very massive stars that one of them in particular is bright enough to ionize the surrounding gas. For my own doctoral research, I looked behind the Orion Nebula, or through it, with radio telescopes, because there's a much larger dark cloud behind this little blister in front. And the dark cloud is not yet lit up because the stars inside have not yet turned on. They're lower mass stars. We call them protostars. But with different kinds of eyes, radio telescopes and infrared telescopes, we can see that process. And so I use the Very Large Array over in New Mexico to study this region for my doctoral research. If we look at some of these objects, you'll actually note that some of the smaller things you might not notice at all are quite interesting. Here's a couple of smaller stars trying to form in this torrent of activity in the Orion Nebula. And magnified here, you see that they are surrounded by dark dust. One of them is kind of oriented face on, the other one kind of more edge on, like a disk. And it turns out these dusty disks are very common around stars that form in our epoch of time. The diameter of these disks is about the same diameter as our own solar system. And so we now understand that planetary systems form in dusty disks around stars as the stars are forming. And in fact, we're finding lots and lots of formed planets around stars. This is an artist's conception, but of a very real system of planets around a star outside of our own solar system. In this case, there are 6 planets that are in tight orbits around their parent star. And they were discovered not by taking a beautiful picture like this, but by seeing that the starlight dimmed occasionally and regularly when the planets passed in front of it along our line of sight. This transit method is very popular now for studying exoplanets. And in fact, exoplanets, which means planets outside of our solar system, are now very common, we know, and we're studying them as a very hot topic in astronomy these days. Back when I was starting graduate school, we didn't know of any planets outside of our solar system. We thought they might be there, but we didn't know how to find them. Now the technology and the techniques have become much more clever and sophisticated, and literally thousands of star systems with planets have been observed, detected, planets confirmed, and we're now trying to understand how to build telescopes that will help us learn more characteristics of exoplanets. All of these features, planets, stars, nebulae, these gaseous clouds, and a lot of what we don't see called dark matter fill the volume of what we call galaxies. So here's a galaxy collection of stars, gas, dust, all held together by mutual gravity. And in fact, over time, some of these galaxies take on these beautiful pinwheel or spiral structures with spiral arms. And if you look carefully in this gorgeous image, you'll see some background galaxies. This, to me, it was just kind of a random galaxy, actually, that I pulled out of the archive of Hubble Space Telescope images of galaxies. But I like to point out that it's so beautiful, astronomers have called it NGC 1309. So astronomers need some help from poets, I think. We can't get far enough out to see our own Milky Way galaxy, but by looking around from inside the galaxy, we can kind of get a sense that we also are living in a spiral galaxy. Here's an artist's conception of our own Milky Way. And if you look toward the bottom of this image, or the bottom half, you'll see our solar system. I don't know if you can see my mouse there, but our solar system, we think, is right along one of the spiral arms. And if we look toward the center of the galaxy, we see lots and lots of stars and activity. If we look off the plane of the galaxy, we see fewer stars. But we think there's probably at least 300 billion stars in our galaxy. So we do live in an incredible universe that inspires wonder and awe. I'll just flip through some of these gorgeous images of star-forming nebulae, the Horsehead Nebula, which is also in Orion, but this image is in infrared, so you see more of the ethereal, dusty emission. I think it looks more like a dragon than a horse, but it's in the eye of the beholder. We now know that there are lots and lots of galaxies. So, and again, that's only been known for the last century. So, you know, we live in a very privileged time in terms of human understanding of the universe. Galaxies come in different shapes and sizes, and as we look at them, they can be in different orientations. Here's a pair, one of them is kind of face on, one of them's kind of edge on as spirals, and you can see how much dusty stuff is in the plane of the galaxy. If we look in a different kind of light, ultraviolet light, we can see those hot spots even brighter along the spiral arms where new stars are forming. So these would be regions where those colorful nebulae, like I showed you in the Milky Way, are being lit up even in other galaxies as stars are vivaciously forming in some kinds of galaxies. Galaxies are even known to merge together. So while the universe as a whole seems to be stretching apart, galaxies being stretched apart with that expansion of space are moving apart from each other. But if you get a case where two of them are close enough, their mutual gravitational pull will dominate, and that will pull galaxies together. So here we have a pair of galaxies that are being drawn together, and we now know that merging of galaxies is a very important part of the development of galaxies over the history of the universe. We think our own Milky Way has gone through some mergers in the past and will merge with the Andromeda galaxy in the future. And when these mergers happen, they can stir up a lot of turbulence. So here's two galaxies a little farther along in that merging process, and it creates a lot of disruption. The turbulence incites a lot of more star formation. So you see all those bright hot spots of star formation in this pair of merging galaxies. And sometimes they even look like they're looking back at you. So these are awesome sights to see, and they do inspire a kind of philosophical reflection. Philosopher Kant said that two things continued to fill his mind with ever increasing wonder and awe the more often and intensely he reflected on them. And those two things were the starry heavens above him and the moral law within him. And I think humanity today is still contemplating on the wonders of nature that we're learning with science, and then meaning, purpose, and values, justice, things of that nature that we contemplate within us as well. And let me just take a little aside here to say that science and technology impact nearly everything about life today, not just astronomy and astrophysics. And so the program that I direct is helping scientists and religious communities and ethicists to talk about these intersections of science. Let me just go back just a second. Science and human values, belief, and doing good for humanity and all life with science and technology. So the dialogue on science, this keeps going ahead of me. This dialogue on science, ethics, and religion, or DOSER program, is part of the American Association for the Advancement of Science. And the AAAS is the world's largest scientific advocacy society, and DOSER has been around for over 25 years now, facilitating communication between scientific and religious communities. And so we do things like public events on all kinds of interesting things, like what's happening in neuroscience, what's happening in genetic mapping, what's happening in ecology. We're also doing longer term projects such as Science for Seminaries, where we're helping the institutions that train clergy to be able to bring more relevant science into the training of who will become future congregational leaders. And kind of a related project to that is this Scientists in Synagogues program that we are partnering with Sinai and Synapses on, and that's helping to sponsor this event right now. We also have a program called Engaging Scientists in the Science and Religion Dialogue to help scientists better relate to a largely religious public. And these are, of course, overlapping communities of some scientists themselves are people of deep faith commitments themselves. We have lots of resources that you might be interested in here, including a wonderful little film series. It's a wonderful conversation starter about cutting edge science and its impacts on society. And so I hope you will check us out. Here's some of our seminary professors. Here's how you can find out more about the DOSER program and our resources. So I hope you'll go to our website and sign up for our newsletter. Check out, we're active on social media. And we also have a new additional website of resources called science-religion-dialogue.org. So you can take a quick screenshot of this if you want and find out lots of goodies to continue these kinds of conversations in your own congregations or in your own home or your circle of friends. And that's because science affects not just the technical aspects of life. Science is influencing us and is a part of nearly every part of modern life. And there's a lot of interesting and challenging ethical decisions about how we use science and technology. And these conversations need to be had from an informed perspective. So let's go back now to our universe, which is enormous in both space and time. I showed you our one beautiful example galaxy, but there are in fact lots of galaxies. This is one of my favorite images from the Hubble Space Telescope, which is called the Ultra Deep Field, pointing the telescope in a direction of the sky where there aren't very many nearby stars, and just collecting light for many, many days to see what faint things show up in the exposure. And this tiny little field of view, it's kind of like looking through a drinking straw, showed up thousands of these little points of light. These are not stars for the most part. I think there's a couple of foreground stars, but everything else in this image is a galaxy, even the tiny little dots of light. And galaxies can contain hundreds of billions of stars. If we could get far enough out to look back at our Milky Way, it would look like one of these spiral smudges in the upper left-hand corner. So imagine each one of these little dots of light containing hundreds of billions of stars. And then imagine this extrapolated over the entire sky. This is the universe that we live in. And there doesn't seem to be a center in that sense. And in fact, some of these galaxies, well, they're all at different distances, right? So some of them are closer to us than others, and it takes time for the light to get to us. And when we're looking at these vast distances, that can be millions of years for the light to get to us, and in some cases, billions of years. And we're seeing them as they were when that light began its journey. And we can use this as a time machine to compare galaxies that are closer to us in space and time with galaxies that are farther away. And when we do that, we actually can kind of line up. It's not trivial to measure the distances to these galaxies, but once you do, you can pull them out and like in this image, line them up where the more distant ones are in the circles on the right and the more nearby ones are in the circles on the left. And you can see how galaxies have changed over time. The ones that are more distant in space, so we're seeing them as they were earlier in the universe on the right, are smaller. They haven't yet gone through as many mergers as galaxies like our own have. Galaxies merge together over time, they get bigger. They eventually, many of them take on the spiral structure, or they lose it when they merge with other galaxies. And generations of these massive stars come and go in these galaxies, enriching the material with the heavier elements that are made within stars, within the fusion of stars. So the galaxies on the left, if you do spectroscopic analysis of the stars and the gas in those galaxies, they contain more of the heavier elements like oxygen and carbon and nitrogen and things that we need for life. So this cosmic time of billions of years has enabled that enriching of galaxies and even the ability for solids like planets to form around stars forming later on, like our own solar system. And so we now know that the universe has developed over billions of years of time, and it continues to mature and change with the production of stars within hundreds of billions of galaxies. And those stars producing heavier elements, those heavier elements enabling the formation of solids like planets around stars like our own. And this is providing conditions that are needed for life to exist and thrive on at least one planet that we know of so far. So does that imply there's a purpose for the universe to become habitable for life? I have just now jumped from the science to questions beyond science. So I hope you recognize that, because the rest of this talk is going to be talking a little bit about concepts that are not strictly science. Science is wonderful, but it doesn't answer all kinds of questions. Science answers the kinds of questions for which it's best suited, which are questions of measurement and how the physical forces of nature work, and how time works and things of that nature. But it's not good at answering questions of purpose or value. And that's why science is good to inform the bigger questions that we as humans have, but it can't really answer all those questions. So a question of purpose is not really a scientific question, but that doesn't mean that it's not a good question. And in fact, this question was asked to a lot of great thinkers by the Templeton Foundation a few years ago. I think it's a wonderful project that they did. And they simply asked quite a few influential people around the world, scientists, historians, theologians, philosophers, does the universe have a purpose? And they asked each one, who pretty much all agree on the science that I just described to you. But they have, as human beings, different responses to this question that's a bit beyond science. And they gave a one-word answer, but then they each wrote a nice little one-page essay that explains their responses. And so you see that these great thinkers don't all have the same response to this kind of question: does the universe have a purpose? You can find out more at this bigquestions.org website. But here's some samples. Here's a scientist who says no to this question. In the absence of evidence, the only reason to suppose that it does is sentimental wishful thinking, which underlies all religion, an unreliable tool for the discovery of truth of any kind. John Hott, however, says, yes, the fact that we can even ask such a question at all suggests an affirmative answer. The impassioned search for meaning, which is perhaps our species' most distinctive trait, doesn't lift us out of the universe. It doesn't take place outside of nature. We are, after all, as much a part of nature as roaches and rivers, and so too is our thirst for meaning. So if we accept evolution, our longing for meaning is nature, in the same sense that birdsong and the howling of woods are nature. And Jane Goodall says, certainly. She says, of course, science typically scoffs at any belief in a God and tells us that we have a God gene and that the tendency toward religious belief is simply part of our biological makeup, as inevitable as the universal human smile. And yet, even if this were so, we would still need to ask why. Why should we be programmed to believe in a God? Why are the laws of physics designed to make life ever more complex? And where did those laws come from? Those are the questions that are a bit beyond what science can measure. And so I like the caution, and I didn't come up with this, but to beware of something called nothing buttery. In other words, when you hear someone say we are nothing but our genes, or nothing but our chemical makeup, or nothing but our brains, that's nothing buttery. And it's just not the case necessarily that the scientific explanation for a natural phenomenon is the whole story of who we are. We can ask if science and theology can come to complementary conclusions, even though they're addressing different kinds of questions and issues. And that's kind of Dozer helps facilitate that. I have to point out at this moment, Dr. John Polkinghorne, a physicist and Anglican priest who has done marvelous thinking in this area. And he just passed away a few days ago after a life well lived of thinking in these realms, writing many helpful books. And he said science and theology are both concerned with the search for truth. In consequence, they complement each other rather than contrast each other. Of course, the two disciplines focus on different dimensions of truth, but they share a common conviction that there is truth to be sought. And I think that's quite interesting. Many people kind of immediately say, well, science and religion are kind of on opposite sides of some kind of conflict, right? And yet he's saying that actually they're both truth seekers. They're looking for different kinds of truth. They're answering different kinds of questions, but both of these enterprises can be seen as truth-seeking enterprises. And then a little more practically speaking, Dr. Edelman, who works with our Dozer program, she's a professor of psychology at Catholic University, recently said that scientists and people of faith speak a common language, which is awe and wonder about the world at large. We can meet on common ground and consider our common interest. So let's talk a bit about significance. How do our views, our discoveries affect our view of ourselves as human beings? Of course, this discussion has been going on for a long time. And when we find out that we're not central or even unique as life forms, that can be interpreted as a loss of significance, if significance is based on position or rareness. But that's a philosophical decision. Interpretations vary. How does being rare correlate with being significant? Are you significant if there's a lot of things like you, or are you significant if you're very unique? And in fact, we understand how the Earth was, the story goes, was demoted when the Copernican theory was found to be correct, that Earth is not in the center of the solar system or of anything. But we're reading sometimes back into it a philosophical reaction that wasn't the case at the time. There's an article in Physics Today by Dennis Danielson, who's a literary expert, who pointed out that in Copernican times, being removed from the center was actually considered an elevation, not necessarily a demotion. Hell was in the center of things, and so for Earth to be pulled out of the center was not necessarily seen as a demotion in Copernican times, even though we look back and interpret it that way today. So what does it mean to be significant? Does it mean to be rare or common or unusual or central or long-lived? Again, the Copernican science was found to be eventually compatible with most faiths and cultures. And so now we have another question of significance, which is, what if we find out that we're not the only life forms in the universe? Will the finding of life outside of Earth or outside of our solar system have the same kind of Copernican revolution kind of impact on culture? Will it shake us to our core in terms of how we think of ourselves? Will it make us seem even more insignificant? Or will we have a different reaction? And how will it affect our view of human significance if we find evidence for life beyond Earth? Or if we find, in fact, that it looks like life as we know it is perhaps very unlikely in these other places, will that also have an impact on our view of human significance? These are the kinds of questions that are beyond science. They're exactly, what does it mean philosophically? How will we as human beings react? We are connected to the rest of the universe. Jill Tarter, leader in the SETI program, the Search for Extraterrestrial Intelligence, has been passionate about looking for signs of intelligent life beyond Earth. And she points out in this quote that we're actually physically connected to the rest of the universe. The iron in your blood came from a star that blew up 8 million years ago. The iron in your left hand came from another star. We are the laws of chemistry and physics as they have played out on Earth. And we're learning that planets are as common as stars. Most stars, as it turns out now, have planets. This is an amazing discovery for our day and age. It's not a new idea. Greek philosophers were speculating thousands of years ago that there must be other worlds and other living creatures and planets. Of course, they were using the word world a little differently than you do. The difference between the speculations that have gone on for thousands of years and today is that we're now discovering lots of places where life might exist beyond Earth, lots of exoplanets. We have not yet discovered life beyond Earth, but we know that we know how to look. In fact, even the nearest star to the sun, the Alpha Centauri system, has a tiny little star called Proxima Centauri, which seems to be potentially have a solid surface, potentially be habitable. It's in the habitable zone of its parent star. So this is intriguing. This is an artist's concept of what it might look like from Proxima Centauri b. And in fact, whole missions lately have been gauging the numbers of stars that have planets. And now we're trying to figure out how many of those planets are in comfortable zones around their parent star where liquid water might exist. This is a graphic of the Kepler mission, which discovered thousands of these exoplanetary systems. And there's a whole field called astrobiology now that is being developed to look at these distant exoplanets, and hopefully even better with future telescopes, to see if we can see signs of biological activity in their atmosphere, since we can't actually travel there. They're too far away. So we would look for things like we see if we look back at Earth that indicate life going on here, things like evidence of oxygen by looking for ozone. Oxygen is a byproduct of plant life here. Or looking for liquid water, which is necessary for life. Looking for reflected light that might give evidence of plants. Looking for other kinds of evidence like methane, biological activity. It turns out a lot of livestock on our planet releases detectable methane in our atmosphere. And we have to rule out other explanations if we see these things on other planets. So studying habitability and what's needed for life on Earth, even in extreme conditions, and how we might look for it beyond Earth is a big process of exobiology now. Could there be other worlds? Well, different religious traditions have thought about this. Historic Islamic thought embraced the possibility. Here's a quote from Imam al-Razi, who said, "The Most High has the power to create 1,000,000 worlds beyond this world." The arguments against that are flimsy, he said. Catholic thought has grown very sophisticated. The cartoon on the right actually came out in the Washington Post a few years ago, but it was a very nice article on the Vatican's Pontifical Academy of Sciences, which has been holding conferences on astrobiology. The Vatican has a Vatican observatory. They're actually doing world-class astronomy, and they consider the idea of questioning whether life exists elsewhere to deserve very serious consideration, scientifically and also philosophically and theologically. Dr. David Weintraub, who wrote Religions and Extraterrestrial Life, How Will We Deal with It? He's a professor of astronomy at Vanderbilt. And he said that Judaism accepts the possibility of extraterrestrial life. Jewish theology may actually require belief in extraterrestrials, since there are no limits on the power of the Creator. Thus, for Jews to say that no life beyond Earth could possibly exist would be unacceptable, as such an idea would appear to place shackles on God's creative power. The universe belongs to God, and God can do what God wishes to do with the universe. Now, the possibility is different from the probability of finding life beyond Earth. Howard Smith, who's an astrophysicist at the Harvard Center for Astrophysics, gives many lectures on his Jewish faith and how it relates to his view of the universe. He said that as an objective look at just two of the most dramatic discoveries of astronomy, Big Bang cosmology and looking at the nature of exoplanets, suggests that we are in fact cosmically special, perhaps even unique, at least as far as we are likely to know for eons, which puts that as a counter philosophical reaction to what he quoted from Carl Sagan above that, where Carl said we live on an insignificant planet of a humdrum star, and Stephen Hawking said the human race is just a chemical scum on a moderate-sized planet. Howard would say, no, actually, our life here is quite unique, and it's hard to have a planet, even if there are many planets, that can create and uphold stable, advanced life that can contemplate itself. And even if there is advanced life elsewhere, it's going to be hard for us to ever interact with that life. In Christian thought, there is openness to the idea of life beyond Earth. And it also creates some challenges in terms of thinking about God's relationship to life on Earth, in particular with the coming of Jesus, who is thought to be God in human form, with Jesus saying, "I have come that they may have life and have it to the full." Would this incarnate God in Jesus make that same appearance to other life forms on other planets if they also had a sense of moral understanding. And so that's actually been a subject of contemplation for centuries, I found out. So there's an interesting question. I realize I need to close up here, so let me just kind of speed up. A theologian, Ted Peters, said that asked many religious groups whether their beliefs would be shaken if we find life, intelligent life beyond Earth. And he asked Catholics and Protestants and Orthodox Christians and Mormons and Jews and Buddhists and people who identified as non-religious, and nearly all of them said that their belief system would embrace and could embrace the idea of extraterrestrial intelligent life without being shaken, without facing a crisis. Some even welcomed it. But the interesting thing is that he also asked them a subsequent question. Do you think these other religious groups, not your own, but these other traditions would face some kind of crisis? And most people said, oh yes, this other religious group is going to have a big problem when we discover life beyond Earth, just not my own. So there's something kind of sociologically interesting and strange going on in what we expect is going to happen if and when we find life beyond Earth. All right, so human responses to the grandeur and perhaps the bewilderment of our universe can span a huge range from wonder and awe and praise to God, to bewilderment, perhaps loss of faith, feeling insignificant, to even gratefulness and curiosity. These are all valid human responses. Blaise Pascal, who's known for writing his deep thoughts and reflections, he shared some of his troubled thoughts about not only the size of the universe, but time. He said when he considers the short duration of his life swallowed up in eternity before and after, and the little space which he fills, engulfed in the infinite immensity of spaces of which I am ignorant, he says, I'm frightened and I'm astonished at being here rather than there. Who's put me here? By whose order and direction has this place and time been allotted to me? The eternal silence of these infinite spaces frightens me. So that's one reaction. So are we significant? It's a philosophical question with many different types of answers. And I would say that perhaps I would posit, and this is my personal reflection here, but that our significance is apparent, not from our place or time span in the universe, but from our existence at all. That we're a product of a universe or potentially a multiverse that's evolved toward life, and our consequential ability to contemplate good and evil and our place and purpose in the universe. That in itself, to me, speaks of significance. So we can feel insignificant, like Carl Sagan says, that we live on an insignificant planet and a humdrum star lost in a galaxy tucked away in some forgotten corner of a universe. But I personally prefer the reflection of the psalmist, who said, "O Lord, our sovereign, how majestic is your name in all the earth. When I look at your heavens, the work of your fingers, the moon and the stars that you've established, what are human beings?" There's that insignificance, that you're mindful of them, or mortals that you care for them. And yet you've made them a little lower than God and crowned them with glory and honor and given them dominion over the works of your hands, putting all things under their feet. I think of that as science. Scientific exploration is a gift, and our lives and our ability to contemplate is a gift. So the universe inspires. I hope you've been inspired today. There's the space window at the National Cathedral, inspiring others. Here's another beautiful psalm, Psalm 19:7, saying that the heavens declare the glory of God, proclaiming the work of his hands without using speech or language, and yet their voice goes throughout the earth. And one way we react also is by continuing to be curious. So I didn't get to talk about gravitational waves and black holes, but there's lots of cool stuff to study. But as we look back on planet Earth, as the view is here from the space shuttle after servicing the Hubble Space Telescope, we see the sun rising gently from behind that wispy atmosphere of planet Earth, and reminding us that our Earth is beautiful and fragile, and we should at least take care of this planet. We know there's life here. Here's some good resources, books, and organizations if you want to take a screenshot of this. And with that, I will close. And if we have any time for questions, I am quite happy to take them.
This has been so thoughtful and inspiring, and has raised so many questions for me. Dr. Wiseman, do we have time to take about 15 minutes to continue this conversation?
I have plenty of time. I just
Okay.
didn't know if you had a time
Okay,
cutoff.
good. So we'll take 3 more hours to continue the conversation.
Okay.
Excellent. So thank you so much. Okay, so I would love to start here. Rabbi Middleman is gonna hold back. He wants to be a listener for now. And here's my first question for you. You know, we talk in Judaism about the Ein Sof, being the infinite. Yeah, that God in particular is infinite. And here we're not just dealing with a spatial reality, but a temporal reality, even a spiritual reality beyond space and time. And I wonder, how do you, as someone who studies dimensions of space, think about a finitude of space? Is there an end to space?
That's a real good question. And I don't even think scientists just don't have a unified answer to that question. And the reason is because it's very hard to know what you mean by that. Like when we look out with telescopes, we're seeing things as we look farther and farther out. We're seeing them as they were farther back in time, as I showed with those pictures of galaxies. But eventually you get to the point where there hasn't been enough time to see anything beyond that. Now, the universe in the meantime has been expanding, and so we know there are galaxies beyond the horizon of what we can see, but we'll never be able to see them because they've already moved beyond the horizon and the light will never get to us. So we cannot see a physical edge to space. We can see a kind of time edge to the universe, meaning that we can look around and see what we call the cosmic microwave background radiation. That's the radiation left over from the beginning of the universe. And it correlates with our understanding that our universe seems to have had a beginning, or at least a burst of inflation about 13.8 billion years ago. And that correlates also roughly, if you kind of rewind the expansion of the universe, you know, we measure the expansion rate and we can kind of rewind that and we get a rough sense of the time span of the universe. So we know that the universe, at least as we know it, has not been here an infinite amount of time. Now, there's ideas that there may be other universes popping off and coming and going. So time may not be the ultimate way of constraining things. So if it sounds like I'm not answering your question, it's because I'm not. I don't know if there's an edge to the universe. It really hardly makes any sense because in a sense, everywhere in the universe that you would look around and it looks like everything is moving away from you as it expands. And so it may be that the universe is kind of, in a sense, infinite, which blows my mind because then that means if we consider matter and energy kind of equivalent and the beginning of the universe basically was energy and over time some of that has converted to matter, it might mean something like an infinite amount of energy. So that has theological implications. So that is a long way of saying I don't know.
Okay, amazing.
Yep.
So to move on to the next question, if someone could write books and dissertations on the idea of the center in theology. And it was fascinating what you brought up over there, that in Copernican times, the center was the center was demoted. I think that was the phrase you used, or the center was not central. And so I wonder what was central. Like in Jewish theology, we do have the center. You dance around the Messiah. You dance around the rabbi. You dance around the bride and groom. We also have an authority figure, which would be kind of up front rather than in the center, like the melech, the king, the godly, the God at the throne. But I wonder when you said in Copernican times the center was the most significant, what was?
Well, that's the good point. So again, I would need to be more of a literary expert or a historian to answer that question. So I don't know, but I do know that it's quite interesting when we try to read back from our current perspective on what we think people centuries ago might have thought about a scientific explanation for something. we might be mistaken. And so that is what I think Professor Danielson was pointing out as a literary expert, that, be a little careful, because we have a modern narrative that says, oh, we all thought that Earth was in the center of everything and humans are in the center of everything. And then when Copernicus was proved right, that Earth is not in the center, this was a huge demotion, and it made us feel, it really, really made us know that we are insignificant and not special. It was a humbling event. And of course it was in many ways, but he was pointing out that actually in the worldview of the time, the center of the Earth was hell, and the center of being elevated out of that, even if that meant that Earth was no longer the center of the solar system, was actually a good thing in that sense. Now, I don't know if that means every sense, because certainly theologically at the time, I'm sure they would put God at the center of what was important in the realms of reality. So again, this is probably a question way beyond my ability to answer clearly, but it does tell us that we need to be careful about reading in interpretations to scientific discoveries in the past using the framework that we've become familiar with today.
Awesome. Okay, we're going to go to a question from Rabbi Middleman.
I always love hearing your presentation. It makes me feel such incredible awe and majesty. And linking actually off of a question that Rabbi Yanklowitz asked, one of the things that I think is particularly challenging for humans thinking about, particularly astronomy, are the gigantic numbers that we cannot get our mind around this. And last year there was a tweet that was there was a year on Earth. If the Earth was a year on January 1st, what would be happening in that equivalent way? And even thinking about if the history of the universe were a year, the Earth would come up in like August or September. And so do you have any ideas or suggestions of ways to even approach or think about these massive distances, these massive timescales that we just, as people who, on a human scale and a human lifespan, have real trouble conceiving?
Yeah, so that's of course hard for all of us. And I think one of the understandable initial reactions that people have when we get even a sense of the enormous size of the universe, the enormous numbers of galaxies, we think there's something like at least 200, 300 billion galaxies just in that part of the universe that we could conceivably observe. I'm not talking about the ones, as I mentioned, that are beyond that. And each one of those galaxies could contain hundreds of billions of stars. And those stars, at least in galaxies like our own, can contain planets, and it just kind of starts blowing the mind. And then when we talk about 13.8 billion years of cosmic history, I can say that number, but I can't really digest it. And then, as you say, when you kind of put out a timeline of what fraction of cosmic time involves human life, it's very tiny fraction, right? And so it's quite understandable for us to say, well, we are insignificant. That's the philosophical choice, because if significance is earned by being in the center of something, or having a long fraction of the time of something, or in that sense, having a long lifespan, then in fact we are indeed insignificant, and we better take that pill and swallow it. But does it really mean insignificance? That depends on how you define significance. And some of those biblical passages talk about significance in a different way, that significance is a gift of God, and significance is being given dominion and given purpose and given love. And even if you are thinking from a more secular perspective, I think the fact that we can have these conversations, that we have the tools to look around in the universe and discover what we're connected to and where we came from, is a sense of significance, that we have an awareness, and that we even have the awareness, sadly, that we do things to each other that are terrible, and recognizing that there is good and evil in this world, and being at least having the choice of doing something about it. So there's different ways of gauging significance. And so for me, I do find it, as daunting as I think about the time scale of the universe. I have to scratch my head and say, why? What is the point of a universe that's taken 13.8 billion years to get to the point where we have people scratching our heads and wondering, why we're here and how we should live? And yet it may not be that measuring the fraction of time that we exist as being a measure of our significance is not the best approach. And in fact, you think about, let's say you're raising a child and you raise the child the best you can, and that child becomes an adult and that child learns on their own. And finally, at an advanced age in life, a situation comes up where they have to make a split-second decision. And if they make one the right way, it will be very good. And if they make it another way, it will be very bad. And because of all those years of training and learning and seeking truth, they make the good decision. But it only took a tiny wisp of their life. That doesn't mean that all that lead up was insignificant. In fact, it was very significant to get them to the point of making the right choice at that right moment, even though that was only a small fraction of their life. So time, length of time is not necessarily a direct gauge of significance.
And it reminds me, there's a great text, and I think it's from Rabbi Simcha Bunim, who said that everyone should have a piece of paper in each of their pockets that they should take out. When they have one pocket says, "For my sake, the world was created." Right. What I am doing right now is the most important thing possible. And the other pocket says, "I am but dust and ashes." Right. I am nothing in the large scheme of things. And you got to take out whichever piece of paper you need for yourself at that particular moment. And they're both true. And I think that really complements what you just said.
Yeah, that's very good. Yeah.
Amazing. So I have many more questions, but I want to pull back to see if other folks here do. If anyone else wants to jump in, feel free to unmute yourself. Okay. Good. So I'm gonna keep us going here a little bit then. So firstly, I think that one of the ways people have described religion in modernity, that's kind of bracketing off post-modernity, as an attempt to give order to chaos. Religion as a meaning-making system gives some sense of order. And David, were you unmuting?
Yes.
Good. Oh, good. Let's go to David.
Yeah. Well, the question I had, we talk about finding life in the universe as we know it. And we sometimes talk about finding life in the universe as we don't know it. And then you talk about a multi-universe. And of course, I don't know, who knows? But it seems to me, within our universe, hydrogen, and then the elements that we know them, that we know of, they all come together. I mean, we sort of know what those are. So it seems to me, if we're looking for life as we know it, we may find it in our universe. But it seems to me to find life as we don't know it, we may need to look in a different universe. What do scientists think about that?
Well, of course, you ask a very good question. The challenge is manyfold. One is that we are very limited in where we as humans can actually go. And, we're hoping, for example, this Mars Perseverance rover can dig up the dirt and pick up stuff that we can look under our microscopes and see if we see anything that looks similar to life on Earth, microbial life. And then if it does, you have to make sure you didn't just bring it there yourself, right? And accidentally you're discovering life that surprisingly looks a whole lot like life on Earth because it came from Earth. There are ideas actually that life on Earth was brought here from somewhere else, because there is a lot of transport just naturally between planets. When an asteroid hits a planet, it can throw up dirt and dust, and some of it, if there's enough energy, can be basically launched into space and then can interact with some other planetary system. So you could imagine transport that way. But we can't go very many places in our solar system yet and kind of physically look at material that way. So we are constrained, especially looking for planets outside our solar system, to remote sensing. And that means we are constrained to not looking directly necessarily at life, but looking at the kind of byproducts of life in an atmosphere of an exoplanet. And so then you have to say, what would you look for that would indicate biological activity in an atmosphere of an exoplanet? And so that's why, you know, if you kind of look back at Earth from a distance, you can see oxygen in the atmosphere. Well, that means there must be something replenishing that oxygen, because oxygen is very reactive. Otherwise, it would go away. And so that's a clue that we have photosynthesis going on the surface of this planet and things like that. But what if it's life that's not like life on Earth, you ask? Well, you know, realistically, we wouldn't know what to look for. So that's, you have to kind of start with what you know before you try to figure out things you don't know. And it does seem to be that there's good reason to think that life has to have some relation to liquid water. So looking for places where there's liquid water is a good, reasonable place to start, earnestly looking for life. And then there is a good reason to think that life, especially advanced life, would be carbon-based. And then the arguments are based on chemistry there. And I'm not an expert there, but there is a good reason to look for carbon-based life. But, you know, of course there could be life. And then there's the question of what exactly is life? And there is not a crisp answer to that question either. So these are complicated questions and not clear answers, but we start by looking around at all the exotic life on Earth. You know, Earth has very weird life. If you look in extreme places, the bottom of the ocean, or these, you know, acid pools in Yellowstone National Park, or even buried in ice, and you find out the extreme conditions under which life can exist on this planet and how you might recognize it. And then you try to figure out how you might recognize that looking in other places, even if you only have remote sensing, and it's not trivial. So good question.
Amazing. Do we have one last question from someone out there? Okay, very good. Well, Dr. Wiseman, this has been very rich. So thank you very, very much for the gift of this time and learning. We're very, very appreciative, and we wish you so much continued success in your work. Friends, just to highlight our upcoming next two events in Judaism and science, we have Dr. Michael